some people will be removed. Right? Why? Okay, so hi everyone. Today we'll go to chapter 4. This is Maths Form 2, chapter 4, Polygon. Today we'll focus on 4.1, regular polygons. So if we read here, start with our class. In our daily life, there is a combination of polygons around us, especially in the designs of buildings. The combinations of polygons produce interesting and diverse forms of art. This geometric pattern can be seen at Tanjung Bunga Floating Mosque, Penang, whereby it has a unique combination of local and Western Asian architecture. Okay. And then, polygon refers to the words poly, which means many. Poly means many. And gon, which means angle. Polygon is named by the number of sides. For larger polygons, mathematicians name the polygon according to the number of sides. For example, 17 gon. There is an example. Okay, next. Regular polygon. Today we go to regular polygon only. So 4.1.1 geometric properties of a regular polygon. And learning standard. Today we learn about describe the geometric properties of regular polygons using various representations. Okay, so a regular polygon is a polygon that has sides with equal length and interior angles of the same side. Okay, there are two characteristics. First, all sides are equal in length. Second, all angles, the interior angles are same. All interior angles are same. Okay. So, like this one, identifying regular polygon. Okay. So, the first diagram here, this is we call as equilateral triangle. Equilateral triangle. And all the angle here are same, which is, let me make it bigger. Okay. The sum of interior angle is 180. So 180 divided with 3 angles. This is 60. Same here. This is 60. And here also 60. Total is 180. And then for second, this one we call as square. Square, where the angle here is 90 degrees. 90 degrees, 90 degrees, and 90 degrees. And square, all sides are equal. Okay, and then we have 5 sides of a polygon. 5 sides of polygon. So 5 sides we call as pentagon. Pentagon. Next, we go to here. Okay, regular polygons are polygons for which all sides are equal and all interior angles are of the same size. There are 2 criteria. Okay, so regular polygons have congruent interior angles. Irregular polygons are polygons with irregular sides. Congruent meaning same. Okay, so if we see here, regular polygon, all sides are equal, all interior angle are of the same side, like this one, 3 sides triangle. So actually this one we call as equilateral triangle. Let me check the chat here. I think I want to stop the chat here because some of you chat not related to the lesson. Okay. So next, 3-side triangle we call as equilateral triangle. That is the specific name for the triangle. Okay. If only 2 sides are equal, we call as isosceles triangle. But this one, all sides are equal. We call as equilateral triangle. This one, 4 sides square, we call as square. This is pentagon, hexagon, heptagon, octagon. Pentagon 5 sides, hexagon 6 sides, heptagon 7 sides, octagon 8 sides. Okay, and then this is irregular polygon, not important. We have also concave polygon, shape like this. So this one has how many sides? Let me count here. 1, 2, 3, 4, 5, 6, 7, 8. And this has 8 sides. We call as octagon. Octagon. Okay. We go like this one. Non-polygon. Circle. Circle is not a polygon because no straight line. Shape that has a curved line like this. And this curved line also not a polygon. Like this one. This one is straight line, but not completed here. Not closed. Shape that is not closed. Not connected here. This is also not a polygon. Okay. And then this is a three-dimensional object. We go to example. Example 1. Okay. Based on the diagram, which one is regular polygon and which is an irregular polygon? So this one, this is of course not a regular polygon. This is not a regular polygon. Okay, we call as irregular. Irregular polygon. Okay, this is a rectangle, not square. This is rectangle. Rectangle also irregular polygon. This one, all sides are equal in length and all angles are same. Have how many sides? 1, 2, 3, 4, 5, 6. This one we call as a regular hexagon. Regular hexagon. Regular meaning all sides are equal. Okay. D, this is a square. So of course this is a regular polygon. E, this is a pentagon. However, this is not a regular polygon. This is a irregular polygon. This one next, this is a hexagon. Again, this is irregular polygon. Okay, next page. Okay, it says here the number of axes of symmetry for a regular polygon is equals to the number of sides of the polygon. Okay, so actually, do you know what is axis of symmetry? Do you know what is axis of symmetry? Let me show you some examples. Okay, maybe I use this one, square. Square. Square has how many symmetries? Axis of symmetry. The answer is 4. The line in the middle, where when we fold the polygon, we have a 2 equal sides. Example, this one. This is the first axis of symmetry. Number 2, this one. This is the second. Okay, and then this is this is the third, something like that, and then the fourth is here. So there are 4 axes of symmetry. Okay, for pentagon, 1, and then 2, 3, 4, and one more is here, 5. So for pentagon, 5 sides also have 5 axes of symmetry. Okay, maybe I erase this one. Okay, we go to hexagon. Hexagon has how many axes of symmetry? Okay, so this is 1. Again. Okay, 1, and then 2, 3. Is there any more? Yeah, got 4 in the middle, and then this one also 5. One more is here. 6. There are 6. For 6 sides, there are 6 axes of hexagon, and this is true only for a regular polygon only. For a regular polygon only. Okay, so example like this one. This is a rectangle. This is not a regular polygon. This one have how many axes of symmetry? The answer is only 2. 1 here, one more here. Only 2. This part, this is not axis of symmetry. No, this is not axis of symmetry. No. So for rectangle, there are only 2. Even though this is 4 sides, there are 4 sides, but the axis of symmetry only 2. Because this is irregular polygon. Okay. So that one cover already. Okay, next. Okay, constructing a regular polygon. So this one you want to construct. When you want to construct, you need to use a pair of compasses. A pair of compasses. I will show you later. And then you need also a ruler and a pencil, of course, to draw. Okay. So for today, I will show you video. Three shape that we need to construct. Okay. So first is equilateral triangle. This is equilateral triangle, and this is the step to draw equilateral triangle. However, I will explain through the video. Okay, and then we'll draw a square. First, equilateral triangle, and then second, we will draw square, and then third, I will show you a video how to draw a regular hexagon. So 3 video. Okay, so let me show you now. Okay, before that, I need to stop this presentation. Okay, so I believe you can see the YouTube already. Let me, before I play, I think I need to off my, I think I need, okay, I play now. Okay, ready?
Let us see how we can construct an equilateral triangle. An equilateral triangle is a triangle in which all the 3 sides are equal and all the 3 angles are also equal. So each angle of an equilateral triangle measures 60 degrees. Now, if we need to construct an equilateral triangle, what measures do we need? Well, we know for sure that all the angles are going to be 60 degrees in an equilateral triangle. What about the sides? Because all the sides are equal, we just need to know one side to construct an equilateral triangle. Suppose we have to construct an equilateral triangle and it is given that the length of one of the sides is 6.5 centimeter. Now, because the length of one of the sides is 6.5 centimeter, the length of all the 3 sides will be 6.5 centimeter. So, we know all the 3 sides and all the 3 angles here. So, while constructing, we can use any of the 3 methods of construction using the 3 sides or 2 sides and 1 included angle or 1 side and 2 angles. So let us first try to construct the equilateral triangle with the method when the 3 sides are known. Now, all the 3 sides, that is AB, BC and CA, are equal to 6.5 centimeter. So first, we draw one side of the known length, that is AB equal to 6.5 centimeter. Now, with A as the center and taking a radius of length AC, which is 6.5 centimeter on the compass, we draw an arc. Again, without changing the radius, that is radius equal to 6.5 centimeter, and with B as the center, we draw another arc. We need to see that the second arc intersects the first arc. So now, the point of intersection of both the arcs is point C because it is at a distance of 6.5 centimeter from point A as well as from point B. And so, we have the 3 vertices of the triangle. We can join AC and BC to get the required triangle ABC. We measure the lengths of the sides AB, BC and CA using a ruler. The sides measure the same, that is 6.5 centimeter. We also measure the angles A, B and C using a protractor. Each of the angles measures 60 degrees. So triangle ABC is indeed an equilateral triangle. Now let us try another method to construct an equilateral triangle. Now, this time, let us try to make an equilateral triangle with the lengths of sides equal to 9.3 centimeter using one side and two angles. So first, we need to make a line segment AB of length 9.3 centimeter. Now, angle A is equal to 60 degree. Now, we need to construct a ray using a ruler and a compass at an angle of 60 degrees at the point A. Also, angle B is equal to 60 degree. So, once again, we make another ray using a ruler and a compass at point B at an angle of 60 degree. Now, both the rays will meet or intersect at a point. This point is the third vertex of the triangle, that is point C. So now our required equilateral triangle ABC is constructed. We can verify it by measuring the sides AB, BC and CA using a ruler. We observe that each of the three sides measures 9.3 centimeter. We also measure the angles A, B and C using a protractor. We observe that each of the angles measures 60 degree. So this is how we can construct an equilateral triangle. You can use.
Okay, so there is the video how to construct an equilateral triangle. And there are two ways to construct an equilateral triangle. Okay, so next I will show you how to construct a square. Okay, so let me make it full screen.
In this video, I want to show how to construct a square when we're given just one side of the square. So here are the steps on how to do it. So the first thing we want to do is extend the line segment in either direction, but we're going to extend it through point B. So here we are extending the line segment. And next, what we want to do is we're going to set the compass on point B, and we're going to construct a line perpendicular to this segment through point B. So we're going to swing the arc from point B on the right side, and we're going to do the same thing on the left side. So now we have two new intersection points here. So we're going to move the compass to one of the new points and extend it a little bit because we need this compass to go more than the halfway point. Like B is the halfway point between this intersection point and this one over here. So now we swing the arc a little bit above point B, and we move it to the other location here and swing another arc in such a way that these two arcs intersect. And now when we connect point B to this intersection of arcs here, we're going to have a line that's perpendicular to the original line segment. Now we could set this to any length that's just obviously greater than line segment AB, because now we're going to set the compass to the length of line segment AB so we could finish this construction. So we extend it to match exactly the length of AB, and now we're going to swing the arc directly over point A, and we're going to repeat that over point B. And now when we do this, this is telling us the location of the other 2 points, but to get an exact location for this point, we're going to move the compass to this intersection point over here, and we're going to swing an arc in such a way that it crosses this one we made from point A. Now, since the length of the compass wasn't changed from AB, that means that all of these distances are going to be the same. So the last thing we can do here is connect all 4 points. So we draw these arcs in, and now we could just name them. All right, this intersection point over here we could call point C, and this intersection point here we could call point D, and we've just successfully completed a construction of square ABCD given line segment AB. If you found this video helpful, please click.
Okay, so that is how we construct a square. Okay, next is a video of a regular hexagon. This is the most important. Usually come out in the exam. Okay, so focus on this one.
In this video, I'm going to show you how to construct a regular hexagon. To do this, we start with just a point. That point is going to be the center of a circle. So we take our compass, put the point on the center, and draw a circle. After I finish with that, I'm going to take my point, put it anywhere on the circle, and mark off an arc. Don't change the compass width. Move it around, mark off another arc, and continue doing that all the way around the circle. Once you finish, those points of intersections will be the vertices of your regular hexagon. So just take your ruler and connect them. As long as you use the radius to mark off the arcs along the circle, you will get a regular hexagon.
Okay. So in exam, this one we call as arc or mark. We call as arc. Let me try to write something here. Okay. Okay, I try to write something. Okay, so this one we call as arc. Why so small? Let me try make it big. How to make it bigger? Okay. What is this? Wait, Again. So this one we call as arc. We call as arc. So in exam, after you complete your drawing, after you draw everything, after you construct the regular hexagon, do not erase anything. Do not erase anything, especially the arc. Because the arc means you have used your compasses. Okay. If you erase this arc in exam, you will get no marks, 0 marks. Make sure you do not erase anything after you draw, you complete your drawing. Understand? Do not erase anything after you complete the drawing to get the full mark. Okay, understand? So I stop this video. We continue with the textbook. Okay, so I believe you can see the textbook already. So we complete already the construction of a equilateral triangle, square, and also regular hexagon. Okay. So one more thing, regular polygons, like for pentagon and also different shape, can be also be constructed by dividing the angles at the center of a circle according to the number of sides. Okay. So next. Okay, we will do some exercise in the textbook. So self-practice 4.1. Okay, question number 1. Determine whether each polygon is a regular polygon or irregular polygon. So for question A, this is a rectangle. So is this a regular polygon or not? The answer for A, this is not a regular polygon. Okay, B. This is a parallelogram. A parallelogram also not a regular polygon. We call as irregular polygon. Okay, C. This is pentagon and all sides are equal in length, sama panjang. Therefore, this is a regular polygon. Okay. D is a equilateral triangle. Of course, D a regular polygon. Okay, E this one we call as a isosceles. Isosceles triangle. This one we call as isosceles triangle. Okay, not very nice drawing in here. Okay, so E, isosceles triangle, only two sides are equal in length, and one more not equal. So this is not a regular polygon. We call as irregular polygon. KF, all sides are equal in length and all angle are 90 degrees, the interior angle. Therefore, yes, this is a regular polygon. Okay, 4G, all sides are equal in length, sama panjang. All sides sama panjang. All sides are equal in length. So it is a regular polygon or not? Actually, by the definition, this is not a regular polygon. However, if you check answer at the text, at your textbook at the back, the answer is yes, a regular polygon. But actually, by definition, this is not a regular polygon because angle, the interior angle, not all the interior angle are equal based on the diagram here. Therefore, G should be irregular polygon. Okay, H, this is a regular polygon. I, this is also a regular polygon. Okay, and then we have one more exercise. This one I will use a word. Okay, this one. This is a question from the textbook also. Question number 3. Okay, so I put image ready. So starting from this one, triangle, until a polygon with 10 sides. Or polygon with 10 sides. Okay, so we start here. Polygon. So number of sides is 3. What is the name of this regular polygon? The answer is, let me type here, equilateral triangle. This is equilateral triangle. What is the number of vertices? I will show you later. What is the number of axis symmetry? For regular polygon, number of axis symmetry equal to the number of sides. The answer is 3. Okay. Number of vertices also 3. But actually, what is vertices? What is vertices? Okay, maybe I show you. Let me copy this one first. Maybe I take this one. This image. Okay, I put in pen. Better. So let me make it bigger. Okay. So this one, this one we call as side. This one. Okay. So this one we call as vertex. Vertex. Okay. We call as vertex. More than one, we call as vertices. Vertices. Vertices, this one is a plural. Plural of vertex. Vertex, singular. Satu. Okay. So, you know, this is a vertex. Okay, understand? This is vertex. So, and this again, there are 4 vertices. There are 4 vertices and also 4 sides. 4 sides and 4 vertices. Okay, so we go back to our exercise here. Okay, next diagram. We have 4 sides here for the polygon. The name of this polygon, very easy, square. Square. This is a square. And number of sides, 4. Number of vertices, easy, also 4. What is the number of axes of symmetry? Answer is 4 also. Okay. And then, what is the name of this one? This is a regular. Actually, we need to type regular. Regular meaning all same. Okay, regular pentagon. This is a regular pentagon. Number of sides 5. Number of vertices 5. Number of axes of symmetry also 5. Okay. For 6 sides, this one we call as a regular hexagon. Okay, number of sides 6, number of vertices 6, and number of axes or symmetry also 6. Okay, this one, we have 7 sides. 7 sides are called as heptagon. So number of vertices same, number of axes or symmetry also same, 7. Okay. Next, for 8 sides, this one we call as a regular octagon. Number of vertices 8, number of axes or symmetry also 8. Okay. Next diagram, this is 9 sides. We call as a regular nonagon. Nonagon. Okay. Number of side 9, number of vertices also 9, number of axes or symmetry also 9. Okay. So one more diagram. This one, Okay, let me make it bigger. Okay. So this one have 10 sides. We call as a regular decagon. Regular decagon. Okay. So number of sides 10, number of vertices 10, number of axis or symmetry also 10. Okay. Now if you can see here, there are 10 axis or symmetry. Okay. So for today, we finished already our lesson. So I just want to remind you, the name of the polygon is very important. Always come out in exam. Okay. Sometimes the exam ask you a question to calculate, but didn't draw. Just a name. Maybe the question like this: find the interior angle for nonagon. If you don't know nonagon have how many sides, then you cannot do. So, please memorize the name of this polygon. Start with this one. This is very easy. Equilateral triangle, square, pentagon, hexagon, heptagon, octagon, nonagon, decagon. Remember, again, the name of the polygon start with 3 sides: triangle, square, pentagon, hexagon, heptagon, octagon, nonagon, decagon. Okay. So I just want to remind you, in April, bulan 4, in April, you will go back to school. 5 April, right? 5 bulan 4, you akan mula sekolah, di sekolah. Okay. So, maybe in our first class, I will ask the name of this polygon. Cikgu akan tanya nama-nama polygon dalam kelas nanti. Siapa tak dapat jawab, kena berdiri lah. Whoever cannot answer, you need to stand. Okay. Oh, so before that, actually, our lesson is finished already. I think I want to stop the recording.